So the task of this course is to basically try to see what type of information computers can extract from musical signals. That's pretty much sort of quick definition of what this course is about. So I would also like to try to make this course as much as possible more interactive. It is going to be pushed a little bit because of things that we will talk about later to be more in a lecture style, so I want to push back to have it a little bit more interactive. So you are here, we can change things and you can ask questions, and I would much rather do that than just sit here and talk by myself. So are there any questions? Let's start with that. No questions. Everybody is completely questionless. Yes, my friend.
Is there a textbook for this course?
Yes and no. It's a little bit like the Schrödinger cat. It's sort of, it is there and it's not there. So there is a textbook. It's authored by me, but you can't buy it in a bookstore. And a lot of the chapters only exist in my brain and scattered in various other documents that I have written over the years. So some of it will be written. So we'll talk about that. But there's no official textbook that you buy and will have all the answers. Other questions? All right. So let's move on a little bit. Let's see, what can I do? This should be on a full screen view, and then I should be able to do this. So I'm going to talk a little bit about course logistics and how this course is going to run. And this is a course that's going to be really experimental in several aspects. It's experimental because it's a new emerging area. There's not, a huge body of established literature about how to teach it and what to teach and what topics to cover. So it is a little bit of a cutting-edge topic. The other thing that's a big experiment, which some of you are already aware, is that I somewhat foolishly decided to open it up to external participants. I had a very naive assumption that I would get maybe 10 to 20 people, and it turned out that I'm now sitting at something like 170 external participants. Now, some of these are not going to be full participants. They are, just curious to see what is going on. Maybe they will view a few lectures and play with some assignments, but maybe they will not be fully fledged involved, but still it is a large number. So that is going to affect some things. And basically all I can say is that if you are looking for a very structured, you do your homework, you finish it kind of course, this is not the course for you. It's not too late to drop out. It's going to be a little bit under construction. I'm going to try to be as organized as possible, but there's too many things that I have to juggle, and some things are not going to work. So I hope that with good faith and effort we can make it work, but if you're really looking for Calculus 1 sort of equivalent, you won't find it in this course. You had a question?
Can we suggest areas to focus on since it's a new course?
Yeah, I will talk a little bit about that as we go. So I'll not answer it now, but we will go more on it. So one question that I frequently get is, what are the prerequisites for this course? And really, I try to make it pretty generic. So, and this is also the prerequisites for the textbook. So I need your help, because one of the hardest things is that you never know what other people know. So I might consider something obvious, but it might not be at all obvious to you. If you are brave enough or kind enough, you can say, this sentence in your book makes no sense. And I might think that it makes perfect sense because I have been doing DSP for many years, but for someone that doesn't have a DSP background, it might make no sense. So what I strive to have is, you need to have some basic high school math, so being able to understand a little bit equations and symbols and variables and things like that. Some probability and statistics is a very good skill to have. A little bit of linear algebra, and some experience with computer programming. So assuming most of you are third or fourth year computer science students, that should be okay. And the last one is not as strict, is some basic music theory. When I say basic music theory, it could be like 2 years of piano lessons when you are in elementary school. Just having a basic idea of what are notes and kind of how do you write music down, what are chords, that kind of stuff. You don't need to, have passed your rudiments or be a music student. Some of you I know have excellent music backgrounds, might be professional musicians, and some of you might have never touched an instrument. I've had students that cover those ranges and they have liked the course. So I try to do that. And the associated textbook tries to be self-contained and has chapters covering the fundamentals. So I try to make it so that if a music student really was interested in that area, I give them just enough DSP to be able to kind of swim in MIR waters. And if they are interested, if they come from a DSP background but have no music background, I have some material that will help. So what I will try to do is we will cover some of that material during the course. I will have some supplementary material that will be outside the main lecture. So if you want a little bit of a refresher in music theory, that might be something that you will do on your own. Either it will be my material developed by me, or I will point you to some online resources where you can find that material. But it should be pretty, if you work on it, you should be able to follow along and do okay. In terms of learning outcomes, this is pretty much what I want you to get out of this course. You can view it as a mini crash course in the digital signal processing, especially those of you who come from a computer science background. You never do that stuff. Obviously, I cannot cover everything in DSP, and I will have to focus on specific things, but it will give you a taste of it. A basic knowledge of machine learning and data mining. Again, some of you might be taking the full-on course on data mining that Dr. Tomo is teaching. There will be some overlap between the material, but obviously you will learn much more in the data mining course. And we will do a little bit of a crash course on music theory. For those of you who know your music, that will be really boring, but that's fine, just go on with it or take a break that week and go somewhere and do something else. So by the end of the course, what you will have is you will have a familiarity with the basic problems and tasks that have been explored so far in the last maybe 12 years, 13 years of MIR research, and what algorithms have been proposed to solve them. So it will be sort of more of a charted territory. And my main goal is that if you open the proceedings of the main conference in the field and you read some papers, you will be able to understand them. So the papers are not exactly light reading, so they have certain terms and concepts that might be unfamiliar, and my goal is by the end of this course to have enough kind of ammunition that you will be able to understand the majority of the paper, and the parts you don't understand, you will be able to look up resources to help you understand it. And also you will gain some experience with designing and developing MIR algorithms and systems. So it's also a very kind of integration course where you take a couple of things and you build something together. So there's a big project component. Yeah?
Sorry, just what's the IS in front of ISMIR stand for?
Oh, yeah. So that's the originally International Symposium and currently International Society for Music Information Retrieval. We'll talk that has a little funny history, which we'll talk about shortly. So it is nowadays it's the International Society for Music Information Retrieval. Workload. There are 3 lectures per week. You know the schedule, and approximately, I really try to do this strictly, something like 2 hours of associated homework expected for each lecture, probably with a bump near the end as you approach project deadlines and things like that. but a totally weekly commitment of approximately 9 to 10 hours. So if you find yourselves working 20 hours for this course, then I would appreciate you telling me about it. Or if you find yourself working 2 hours or 3 hours just attending the lectures and doing great in the assignments and everything, I also would appreciate it because I need to sort of scale the difficulty to that. And that's something that I can only know, like if I grade an assignment and it's a perfect assignment, I have no idea if it took you 1 hour, 2 hours, or 8 hours. And one time that I did a poll asking students that, I received lots of replies. Like I had an assignment and it ranged from 1 to 2 hours, but there were a few students that said 16 hours. So, were they lying? Were they not? I don't know. But so the assignments will typically combine some reading and understanding of MIR literature. So you will be tasked to read a particular paper and answer some questions about it. So be prepared to do some reading in this course. And also some programming of MIR algorithms. This is not really a theoretical course, but it will be more, it's not like you will be programming some big system. It's more like you will be programming something that will help illustrate a particular concept or clarify a particular idea. So the programming itself is not the, let's say, the final outcome. It's a means to an end, which is to understand the concepts. And there will be a final group project, and we will spend a bit of resource, mostly bit of time, mostly off-class time, doing this kind of strange marriage process of finding projects and finding partners and deciding what they will be. But there is a group project, and to some extent that will be, unlike the assignments, which will be the same for everyone, the group projects will be selected by you, and you have some freedom in terms of what you're going to do. So are there any questions on the prerequisites and the workload? Yep?
There are no exams?
There are no exams, no. Yep?
Does the final project include a final presentation?
That's a good question. So in the past, yes, every single time I had a final presentation and it was nice. We would all get together and sit around, and the students would do a presentation and we would have some donuts, and it was great. The problem with this year is that even forgetting about the external participants, even the course itself has more students than usual. So typically I had about 15 to 20. This year it's about 40. So it's more people than the people you see here. So what happens is that with so many, it's hard to schedule so many presentations without taking too much time. So my current inclination is to actually go for something like you will have to prepare some kind of demo where then they will all be hosted somewhere, maybe even the course webpage, and then people will vote on them. Maybe we'll have one meeting where we discuss them, but not do presentations in class, simply because there's not enough time. There was another question?
Yeah, so just to clarify, there are 4 assignments, 1 final group project, and that'll be all the work for
Correct.
course?
Yes.
So the final project will be 60% of
correct.
Okay.
So the final, I should have written that. So 40% is the assignments and 60% is the final project. And the final project has some phases. So it's going to be like project phase 1, phase 2. So it's not like a one final thing. There's some deliverables that happen during the term. So all that will kind of gradually be revealed. But also, you won't have much workload in terms of assignments until like another week or two, because that's by the time you get enough background so I can actually ask you to do something that's meaningful. Okay, other questions? All right. So external participants. So I decided to open this course to external participants, and one question is, why would you want to do that? The reason is that I was partly curious to explore the idea. There's all this, there was this kind of hype and crash wave of MOOCs. Some of you might have heard that term. They're massive online courses. Initially, there was this feeling that they would suddenly replace completely people like me and make them obsolete and make traditional brick and mortar universities obsolete. There was a lot of investment and hype. It looks like things are not going so sweet in that direction, and they're having some issues, or at least they don't have as much the momentum as they had in the beginning. But I still think it's a good idea, and it's especially a good idea in a course like this, where, you know, it's not like calculus, where every single university on the planet has a course on calculus. There are maybe 5 or 6 places in the world that offer this type of course. So there's definitely a group of people who just simply would never have access to this type of course unless someone like me decided to offer it. So in any course, there are 2 components. There's sort of a component of knowledge delivery and a component of assessment. What I have decided to do is simply ignore assessment completely. So none of the external students are getting any credit or any recognition that they have completed this course. I'm not going to grade their assignments. I'm not going to do any of that stuff. What I'm going to do is I'm going to give them access to video and audio recordings of the lectures. In some cases, I might do the actual lecture, like, you know, what you guys are listening. In some cases, I might record separate videos on my own that cover approximately the same material. And a lot of that, I'm still experimenting with the technology. So I'm still not sure, am I going to do all screencasting? Am I going to bring a camera here and take pictures of the board? Am I going to have you be filmed, put people on live hangouts, all this stuff? So I will play with these ideas a little bit, but hopefully we can make it work. I will give them answers to questions. So if someone external has a particular question on MIR, I'll try to answer it. And I will also provide model solutions for the assignments and some kind of grading rubric. So if you are an outside person and you want to self-grade yourself, you can do a self-assessment test and see how well you do. In that way, you can cheat yourself, and, you know, it's up to you. Like, I don't have to deal with it. There's going to be 2 main points of contact, and you really all need to get on it. This is not sort of optional thing that you should do if you are interested in interacting with external participants. I'm only going to use 2 channels of communication for this course: the Google Plus community and the textbook course webpage. The textbook course webpage has all the material that's relatively static, and it's things like the current draft of the textbook, assignments, slides, videos of the lectures. The Google Plus community has more interaction, questions, different discussion topics, and things like that. Because of the large number, I would really like to minimize the use of email. So for example, if you have a question about the course, I would much rather you post it on Google Plus, and that way my answer will be read by everyone, and you know, that way I don't have to answer the same question many times. It just works better. If it's something really personal and you don't want to share it with the rest of the world, obviously you're welcome to email me or come to talk to me. But the more we can have things public and transparent, the easier it will be. And also, I have to say, the other thing is that the external participants are an incredible resource, because some of them are actually quite experienced MIR researchers. So there is a good chance that if I am not able to reply right away, someone else might step in and provide a reasonable reply to your questions. And also, I'm going to try to do some Hangouts on air. I already did one. If you go to the Google Plus, you will see the first one I did, where I basically broadcasted from my office, and anyone can watch it, and then it gets archived to YouTube. So we might do some live class, I don't know for sure. And then Google Moderator is the other thing I'm going to use. You will get an email from me or an announcement on the G Plus community, or both, about Google Moderator. The way it works, has anyone used it before? Google Moderator? Okay, the way it works is that you can post questions. So either you or me can post questions. And then everyone can vote questions up or down. And then it tallies the votes, and the questions that get the most votes propagate upwards. So I did that for my morning class, which I have 230 UVic students, and I posted some questions. They posted some questions, and then they voted up, and then I could look which ones are the popular questions and answer them. I will usually try to answer everything, but for example, I might decide to answer some live in the lecture that are popular, so to speak, and some of the less popular ones later offline. And that also solves the problem of shyness or thinking that that's a stupid question and so forth. And I want to be really clear about this. There's no such thing as a stupid question. Pretty much all interesting stuff happens because somebody asked a stupid question. When Einstein asked some questions about motion, everyone thought he was stupid, and then he ended up coming up with the relativity theory. So there's no such thing as a stupid question. Feel free to ask anything that comes to your head. So as I said, regarding the textbook, notes for this course are in the process of evolving into a textbook. It is under heavy construction, and I hope to use this offering of the course as a motivation to get it closer to completion. So I already have received from the external participants 1 or 2 typos, and I expect also, you're welcome to send me feedback. Don't hold back. Feel free to say this is complete crap, makes no sense. I just, the more help I get, the better the textbook will be. So I will have the current draft on the webpage. It will be frequently updated and dated, so probably almost every lecture there will be a new version of it. And it might look, right now, it might look like there's a lot of material in the first chapters, and then the remaining chapters are completely empty. They're placeholders. But as I said, a lot of it exists in my brain, and a lot of it exists in chapters and journal articles and conference articles that I have written that I will be transferring and editing as the term goes. So hopefully it will be growing in sync with the class. So now I'm going to talk a little bit about my own background, just to give you a little bit of context of how I came into this area and what I have done in this area. So I did my undergraduate degree in computer science at the University of Crete in Greece. And then I moved to the United States for graduate studies, where I got a master's and a PhD at Princeton University. Then I moved to Pittsburgh at Carnegie Mellon University, where I did a postdoc in computer science for 1.5 years. And since 2004, I've joined the University of UVic, and sorry, not the University of UVic, the University of Victoria, otherwise known as UVic. I also kind of have led a parallel life of trying to keep up with music, so I've done tons of courses in music theory, saxophone, piano performance, composition, and I'm pretty okay in all of them, but also heavily suffer because I'm not a professional and I haven't been able to put as much time as I would like. But I do have a pretty decent music side of things. So my research is interdisciplinary, and the connecting theme is making computers better understand music to create more effective interactions with musicians and listeners. And audio analysis is very challenging, and that's something we will see in this course, partly because there's a large amount of data involved with audio signals. And I've added this because big data now, it's very fashionable. I was doing big data way before it was fashionable. I will probably be doing it way after it's fashionable in some other term. So kind of the general terms, areas that I have worked on are music information retrieval, digital signal processing, machine learning, human-computer interaction, artificial intelligence, multimedia, robotics, visualization, programming languages. And all of these, one way or another, we will touch briefly upon in this course. So this is a course that has tentacles that reach all across computer science, and it's really fun. That's one of the things I really enjoy it, is I can pick any topic in computer science and somehow twist it and make it relevant to this research. But it can also be a little bit frustrating and hard because you have to kind of speak the language of all these different areas. Work experience beyond academia, I've mostly remained an academic, but I've done some internships and I've done some consulting. So some things related, I worked on an early audio fingerprinting system, one of the earliest ones. I worked on a male-female voice discrimination system for phone dating services, processing tons of recordings a day. One thing that we will also be looking at in this course is Marcias, which stands for Music Analysis, Retrieval, and Synthesis for Audio Signals. It's a software framework in C++ with Python bindings and with lots of other things that was started by me in 1999, and it's been going strong since then. There have been 2 major rewrites from scratch, lots of downloads, projects in industry and academia, and it tends to be relatively fast. So I always have a very weird kind of relation with Marcias. If I was talking to someone teaching a music information retrieval course in another university, I would highly recommend it. But because it's my own baby, I feel really guilty about shoving it down your throats, especially because you will have trouble with installation and with other details. But at the same time, over the years, initially I almost didn't say anything. I said, use whatever you want. Then I decided, okay, I'll give some assignments that involve a little bit of Marcias, and the feedback consistently that I have received is they wish we had done that a little bit earlier. So I'm going to be doing that. Now, saying that you can do assignments in any way you want, it's just that I will give you a little bit more of scaffolding, skeleton code in Marcias than if you're starting from scratch. But you can certainly choose whatever environment you want to use. So then I also spent 6 months, maybe 2 years ago or something, at Google Research, and that was a great experience. I worked on cover song detection. Obviously, in all these projects, I worked as part of a much larger team, and there was existing work before I came, and they continue the work after I left. But cover song detection is applied to every uploaded YouTube video, so that's a lot of data. 100 of hours of video are uploaded to YouTube every minute. Content ID scans over 250 years of video every day and matches it to 15 million references. So that is, if you upload a video with a recording of a song that's in that database of 15 million references, and your video starts getting a lot of hits and YouTube wants to put advertisements in it, they detect that you used a song by whoever, Lady Gaga, then they have to pay Lady Gaga money, or they have to tell you to take this song off. And that matching the fact that you're using a song by Lady Gaga is what the content ID does. If it's a recording by Lady Gaga, it's content identification or audio fingerprinting. If it's your own version of a Lady Gaga song, then it's cover song detection. And those are slightly different, but they both are protected by copyright, and YouTube actually checks for both. I also worked on the audio fingerprinting. That's part of Android phones. So if you have a modern Android phone, you can hold it. It can listen to a song, and it can find what song it is. And that functionality is audio fingerprinting. So I got some pending US patents related to that. Okay, so we'll now talk a little bit about what we will cover in this course. But before I do that, let me ask if there are any questions. No questions? All right. Second thoughts? No? Okay. So the detailed lecture tentative schedule can be found in the G+ community as well as the webpage. And I did that intentionally to reinforce the idea that by the end of today, I want every one of you on G+. I apologize if that forces you to become part of Google+ and whatever. I thought a lot about what platform I was going to use. I looked at EDX and online platforms. I also looked at using Moodle or Connex. And at the end of the day, Google Plus was the easiest, and it had pretty much just what I wanted and nothing extra. So it pretty much works nicely. And the Hangouts are a really nice feature because you can really reach a lot of people that way. So if you want to see the schedule, what we're going to do is we're going to go here. This is the how the Google Plus community looks like. There are some new requests to join by a guy named Thomas Grill 7 minutes ago. So I'm going to approve him. Welcome. And if you look down here, I just posted this. So this is not particularly old. This is the schedule of the course. And this is a draft, so it might change as we go. But so can you see it, or should I make it a little bit bigger? Maybe a little bit bigger. Is that good? Can everybody read it? Okay, so today we are going to have an overview of course logistics and talk a little bit about history and tasks in MIR. And for the next couple of days, my goal is to scare you away. So I'm going to be talking about digital signal processing, and hopefully some of you will be scared and drop the course. For those of you who survive that, we will then go to talk about monophonic pitch analysis and autocorrelation, audio feature extraction, and then we will have a lecture where we'll discuss projects. So we need to make, you will need to start thinking about projects early on, and you will have to make a little bit of a blind faith decision on what project you are going to do. Then we're going to have some lectures on data mining. So this will be a crash course on machine learning and data mining. And there will be 3 days, these days, January 27th, 29th, and 30th, where I will be in Greece for evaluating a college there. So I'm not going to be physically present here. So what I decided to do is I have some topics that are a little bit standalone, like they don't depend on things before and after. And what I'm going to do is I'm going to just record the lectures and you can watch them on your own. So if you want to go to Hawaii, in addition to the reading break, that might be a week you can do it. Or if you want to come here and watch them together in cold Victoria weather and sort of commiserate together, that's also fine. But I'll be away during that week. So then moving into February, we will talk about music classification, auto tagging, multimodal classification. Middle of February, we'll talk about rhythmic analysis, clustering, sequence mining, dynamic time warping, hidden Markov models, query by humming, which we will explain a little bit later, pitch representations and chroma, and then here is the topics of the last part of the course: audio score alignment, chord and key detection, cover song detection, structural analysis, sound separation, auditory scene analysis, evaluation, user modeling, visualization, interactive MIR interfaces, computational ethnomusicology, computer musicianship, audio fingerprinting and watermarking, symbolic classification, and musicology. Intentionally, the topics become a little bit more niche, specialized, and maybe a little bit less interesting as you go towards the end of the course, because I know by that time you're brain dead and you're dealing with other courses and project deadlines and things like that. So that's why. In the same schedule, you also see the assignment schedule. So basically, it's sort of the first assignment is due February 1st, and the second assignment February 3rd, and the second assignment will be posted on that date and so forth. This is the project phase 1 and project phase 2 and so forth. And you have it here. There are 3 phases to the project, 4 assignments, and A1/A2 means A1 is due and A2 will be posted. So all the information is there. If something is missing, let me know, and I will take a look and deal with it. So we'll go back here. and enter full screen. So now I'm going to talk a little bit about the history of music information retrieval. How did this field came about and what it is about. I assume that for many of you, some of the terms that I showed you in the syllabus make no sense. You don't know what they mean. So we'll also briefly talk about that and try to give you a sense of what these tasks are. I will also be giving you, after each lecture, or somehow I'll figure out how, sort of what you should read. So there will be suggestions of what material to read for this lecture from my draft textbook and also from other publications. So that will be, in some of it, so let me put it this way. So for every lecture, I'll tell you read this. Obviously, I'm not going to test that you read this, but some of those readings will be used for questions in the assignment. So it will save you time if you don't wait for the assignment. You sort of keep reading on them. It will spread out the workload more evenly, which is always a challenge. That's one of the primary challenges of being a student or a professor, is to spread out workload evenly and not accumulate near deadlines. Okay, so let's talk briefly about history of MIR before computers. So what do we mean by music information retrieval? I'll use a very unofficial kind of definition. How do you encounter a new piece of music? How do you learn a new song? Or how do songs propagate in time and space? So for probably the most ancient way of learning a new song, and probably the way that most of us still learn new songs, is to listen a performance. Like you literally physically go to a place where a musician is playing, or your mother is singing, or music is being created live. The thing is happening right there. And that's how you learn. You learn Happy Birthday by hearing many times the Happy Birthday song being performed in birthday parties when you were a child. What other way do we have of learning about music? So that was pretty much the main way for a long, long time. The other way is music notation. So we know much more about the music of the 17th or 18th or 19th century than we know about the music of the 10th or 11th or 12th century, partly because they use notation much more. And notation doesn't capture everything. For example, we have music notation from ancient cultures. There's some cuneiform notation, and there is some ancient Greek notation, and we know that it represents music. We even know a little bit about kind of the theory behind it, but we have no idea how it sounded. It's sort of like you know the symbols, you know some of the theory, but you don't know how it sounded. But by the time you reach sort of common music notation, classical music times, a score captures enough that you kind of can retain the identity of the piece. So if you hear a piece by Beethoven or Mozart or Bach, the only way that we now can hear that music is because it was preserved in written form, and now it's also preserved in recorded form. So the other way that music can travel across time and space is physical recording. So the invention of recording was a major milestone in the history of music. And it was also a very strange process, because music is really a live, ephemeral thing. It only exists at the moment of creation. But suddenly it became something that you could preserve sort of in a way that was very strange. So there's if you read the textbook, I have I expand a little bit upon this, because there's some really fascinating stories about the invention of recording, about psychologists writing articles saying that people listening to music without seeing musicians were going to be turning schizophrenic, because they would only hear, like if you are crazy, you hear sounds in your head. But that's what happens when you listen to a record. You don't see it. So there's a funny story. There was this British guy, probably had more time and money in his hands than usual, who was compelled to make these elaborate doll houses for each of his favorite operas. So when he wanted to hear an opera on his wax kind of gramophone, he would put it on, bring his dollhouse, set it up, and listen to Carmen so that his brain would not go crazy by not having something to watch while he listened to music. Of course, to all of you sort of brainwashed headphone people, that sounds very bizarre. You're quite comfortable with putting your headphones on and blocking the rest of the world and just listening to music. But maybe we are all schizophrenics and we don't realize it. Then the other thing that I find really fascinating is radio. So radio changed quite a bit the model of music. So before radio was used heavily for music, physical recordings were the primary way that artists would make money. They would sell records. With radio, what happened is that radio became a way for artists to sell records as advertisement, and also became a way for other things like cigarette companies and car companies to advertise their products. And radio really took off in between the two world wars in the time of Great Depression, because anyone can listen to a radio. You just get a radio and you listen to music. You didn't have to pay for it other than buying a radio, and radios were somewhat cheap, or you could just go to someone who had a radio and listen to it. And that model is now playing exactly itself out in the battle that's happening between iTunes and Spotify, Pandora. So last year was the first year in human history in which the digital music sales went down. So digital music sales, obviously they never went down before because they started at zero and then they just went up. But for the first time they went down, and the primary culprit is streaming services. So people will listen to a streaming service like Spotify and they won't bother purchasing tunes on iTunes. And the same kind of thing happened with radio. Like there was a lot of resistance in the beginning of radio from musicians, and musicians would sort of forbid their music to be played on radio and things like that, and it all worked out eventually. So now going to music information retrieval, there was not a lot of history before 2000. Sorry for the typo, that should be a different thing. There were scattered papers in various communities. Some of the symbolic processing work was mostly in digital libraries and information retrieval venues. And audio processing, which was less explored, was mostly in acoustics and DSP venues. So the real kind of birth of the field as a separate research area happened in 2000, and it was the first international symposium on music information retrieval, and it was called a symposium because it was really an informal gathering of people interested in that area, trying to see, what was everyone doing. And there was funding from the NSF Digital Libraries Initiative, and was organized by some people, Stephen Downey, Tim Crawford, and Don Bird. And the thing that happened is, until that time, those two communities were really separate. There was a symbolic community, and there were a few people, including myself, who were kind of messing around with audio. And we had no communication. We went to different conferences, we looked at different things, we used different algorithms, like nothing in common. But just sitting there and having beers together, we decided that we had things in common, and that's an interesting field. So since then, there were about, I break it in 2006 because in 2006 I organized ISMIR in Victoria, so it was a big milestone for me. So up to 2006 there was rapid growth, and then there has been a little bit of a slower growth and a steady state, but there's quite a bit of activity. Also there's quite a bit of companies and industrial applications of MIR, and we will be talking a little bit about that in future lectures. So I think I'm out of time. I still have a little bit more to talk about, but we'll have to do it next lecture. And also I will be posting some material online for reading and so forth. Please sign in on the Google Plus community, bookmark the course webpage, and engage. So engage in the course with questions, become more interactive, and it will work well. If you just expect something where you do the assignments and you finish them and you never talk to anyone, this is not a good course for you. Okay, take care.